Good day. Welcome again to our Let's Review episode. So for today, after discussing some of the concept in terms of centripetal force, now let's move on to calculating or computing for the work. When can we say it's a work? So it has different meaning in terms of somehow and how we think about what work is. But in science, it's a different one. So let's find out. Our competency for this week is to describe how work is related to power and then energy. So how are they related to each other? Please take a look at these two pictures and I want you to determine which is which. So I have your guide questions to answer. Number 1, how do you feel after running upstairs in a few seconds? As you remember the two pictures, one is walking upstairs and then the other one is running upstairs. So if you're going to do that, how do you feel after running upstairs in a few seconds? Very tiring, am I right? So how about after walking slowly upstairs? Is there any difference between the two? You just get tired. But I guess running is much tiresome than the walking up the or slowly upstairs. So what about this work and power? Let us identify. Let us describe how work is related to power and energy and calculate amount of power and work with relation to time. So therefore, when you walk up flight of stairs, do you work because you are lifting your body up the stairs? Take a look at this example animation. So the question is, do you work because you are lifting your body up the stairs? What do you think? You do the same amount of work whether you walk or run. That's the answer to that question. Again, whether you walk or you run, you are doing the same amount of work. How come the same amount of work was exerted? Analyze how come and why is it that you become more tired when you are running upstairs? So today we're going to reveal that. Power, let us define it first. Power is the rate at which work is performed or energy converted. This means that the faster a person works, the more power he or she exerts. I guess you agree with this one, that whenever we want to finish our work very fast, we need more power or we exert more power to do that. So the equation to find or to calculate, solve for the power is that you need to divide work given in the work problem divided by to the time. Or if the work is missing in the word problem, then find the force, divide it to the distance, and then divide it to the time. So P represents the power in watts, capital W for work in joules, and T for the time, and the unit used is seconds. So again, the unit for power is watts, for work is joules, and then for time, second. For force, automatically that's Newton, and for the distance is meter. So in special case that the force and displacement are in the same direction, the equation can be simplified like this. Like if you want to find power, then just multiply the force to the given velocity. So F for the force and V for the magnitude of constant velocity in meter per second. So then again, the unit for power is watts, Newton for force, and meter per second for velocity. This further proves that power is all about time. Like what I told you, you want to finish your work very fast, you'll be needing more power to do that. Or when you exert a force on an object causing it to move quickly, you are giving large amount of power to do work on that object. It's like in the law of acceleration. Force is directly proportional to acceleration. The greater amount of force you exerted to the object, then there will be a greater acceleration. Same with power, I guess. The more power someone is, or the more powerful someone is, the more work he or she can do each time, like some other superheroes. So let's compute or let's solve this word problem as an example using the formula given to you. So how much power is required to do 200 joules of work in 4 seconds? So what if you do the same work in 2 seconds? Did you notice anything? See what you noticed. So let's find out the given first in the word problem. 200 joules, that is the given for work. Am I right? And then 4 seconds is for the time. So how are we going to calculate per power? To solve for the power, all you have to do is to divide work to the given time. So if I'm going to divide 200 joules of work in 4 seconds, we may have then I'll maybe having 50 watts of power. I need that 50 watts. So what if you do the same in 2 seconds? If we're going to divide 200 divided by 2 seconds, then it is 100. And did you notice anything? If we're going to divide 200 to 4, it will give you 50. That is for 4 seconds. But if you want to work that fast in 2 seconds, it will give you 100. Did you notice anything? Yes, of course. The lesser time you're going to do that work, it means there will be a greater power needed. So 50 is less than 100 watts. So I guess that proves that power is somehow the rate of doing things. If you're going to work fast, you are using a larger amount of, or you'll be needing a larger amount of power to do that thing. So I guess that's it, and I hope you learned something from our review about this work. So work, power, energy. Hope to see you again to our next review. Thank you very much, and bye bye.